Escucha, por favor, alguien que confirme por el chat. Ok, muy bien. Entonces, gracias por mantenerse en sintonía. Gracias a todos por estar aquí. En esta nueva charla tendremos a Mari Grigleski, quien nos estará compartiendo sobre event streaming and processing with Apache Pulsar. Ya saben, pueden utilizar el feature de Ask a Question para hacer alguna pregunta y mantenerse atentos a los polls y demás. Nada, atentos a esta sesión, a esta nueva charla. So, hello everyone, welcome to this new session. We're going to have Mary Grigleski, Java champion and senior developer, and she's going to be sharing with us about event streaming and processing with Apache Pulsar. Mary, thanks for being here. Welcome to JConf Dominicana, to the Java Dominicana community, and the scenario is yours.
Thank you very much. Thank you for the introduction. Thank you to everyone who has joined my talk, especially on a weekend, on a Saturday, when you could be doing something else. I think, it's always exciting on the weekends and in the summertime and all of these things. So thank you, thank you, thank you. So let me kind of get myself ready and then I can start. I won't block my screen. So I hope everybody can see me okay here. So I'm going to start now. As such, it's already time. So yes, welcome everyone to my talk on event streaming and processing with Apache Pulsar. As such, right, Pulsar is an open source project. So that's what I want to put my focus in, is on Apache Pulsar, and also then introduction to event streaming, distributed messaging, and processing first before I get into Pulsar. So hopefully it will give you a taste of it, that you will find it attractive, that you want to actually start looking into it, because it truly is a very powerful streaming platform. Okay, and let me kind of advance my slides. So before I start too, if you like to follow along, this is how you can access my slide deck using this bit.ly short link. I'll just leave it up here for like 10 seconds or so if you want to scan the QR code or quickly copy the bit.ly link. So that, yeah, if you want it, then you can follow along. Now, the thing is, even if you miss it, don't worry about it, because I'm going to share the link with the organizers here after the talk as well, so that you can also get access to this slide deck and follow, and read it, view it anytime you like. Okay, so I think my 10 seconds is up, so I'm going to advance to the next slide. First of all, let me introduce myself. But also, too, I wanted to thank the host here, who just kind of so kind and introduced me already. So I am a senior developer advocate at DataStax. So DataStax is a company that does, if you're familiar with Cassandra, with NoSQL. So DataStax is all about open source, but started off doing Cassandra, big data, NoSQL, columnar data, right? Database, data store, all of these things. So the company also realized that it was time to kind of expand into newer areas. And of course, dealing with big data these days, I think streaming is become kind of like the natural kind of go-to thing that we need to venture into. Now, I recently joined DataStax, and I was with IBM previously for 3.5 years before this. So I joined DataStax like 5 months ago. And anyway, so streaming is the area we want to get into, and the choice of platform is Apache Pulsar. And as I myself get more into Apache Pulsar, I really find it to be very promising, and I want to share that with you today. So again, this is like all cloud native type of platforms too. So it's really kind of not very hard to use, and even though it's open source and DataStax, we have our managed Cassandra platform, in which you can also leverage on the platform to actually run your Pulsar systems or application, or the Pulsar clusters as well. So now there are other vendors too. I'll also mention it later. But the thing is, of course, I would like to advocate you to use DataStax. I believe it is very easy to kind of get your hands into. Okay, so now, the thing is, yes, I'm based in Chicago. I'm a Java champion and president of the Chicago Java Users Group. And you are all invited to join our meetup as well. So far, we are still running online meetup. So I also will be sharing the link with you, or you can find us too on meetup.com. You can find Chicago Java Users Group. I also help out with other, meetup groups too in the Chicago area. And basically, too, before I became a developer advocate, which is, I've been doing it for over 4 years now. I was a developer like yourself, maybe many of you in the audience, developer and a software engineer for over 20 years in Java area. So my area covers, right, design, development, implementation, integration, deployment, all kinds. And in recent years, the past 4 or 5 years, I've kind of more ventured into doing event-driven, reactive systems, reactive Java, open source, and also like cloud-enabled like distributed systems. So those are kind of my area. And if you want to stay in touch with me, I will share too with you the link. But for now, if you want to quickly kind of see how you can get a hold of me, I also have the link of my Twitter. So follow me on Twitter, on my LinkedIn profile, please connect. And also I have a Twitch weekly stream normally, right? I usually do it too, even if I'm busy. But unless I'm like on travel, I kind of usually would run my Twitch stream for about an hour and a half or so every week. And then I also have my Discord server if you like to get some conversations going, because I'm not, kind of far away. I'm here. And if you want to get in touch with me, that's how you can talk with me too. So, okay, enough of myself. This is just another kind of pictorial description of who I am, right? Passionate advocate is the main thing. I'm also Java champion, and all of these other kind of major frameworks that I've worked with are here. Streaming, distributed systems, I've done some reactive systems, and IoT, MQTT work as well. Okay, so let me start, right? So event streaming and processing using Apache Pulsar. So this is the agenda for today. Again, I will start with a bit more of a basic concepts, because assuming that maybe not every one of you in the audience have worked with events or familiar with it. So to me, I think, it's not an issue at all. I mean, there's so many things in life, right? We all are specializing in something. So I want to kind of introduce this to you, coming from somebody who have kind of spent a fair amount of time so far on, kind of doing this kind of work. So I want to share with you some basic concepts to clarify, because there are a lot of confusion that I feel, in the market these days. So some introduction to the terminologies, and then getting into the semantics, which is pops up or queuing, and then also answer the question as to why, why event streaming. You don't necessarily have to use event streaming to do your work, yes, but also too, there's a big advantage to it, so we'll discuss that. And then I'll then introduce you to Apache Pulsar, and also highlight a couple of the developer features and the dependencies of it on Apache Zookeeper and Apache Bookkeeper. And then we'll also kind of have a bit of a comparison as to, what I feel too is that Apache Pulsar is a step up from, for example, a platform, also a very strong messaging platform that also offers streaming capability, which is Apache Kafka. So I feel that it is kind of a step up from there. So it also depends on what your needs are. So, okay, with that, let me start. So the many facets of computing events, right? So I feel that events, it's really the way to go in terms of doing modern systems. And why? Because, of all of these things that it is capable of. And, most important of all, doing work, doing any kind of computing, the event-driven way is actually closely mimic how human beings function. Now, think of the fact that would you, kind of like call someone, if you say, okay, hello, this, and then you have to kind of finish your talking and say, okay, I'm done, over. And then the other person will kind of answer and talk about what they want to talk about and then answer. You cannot actually interrupt the conversation, or kind of, not so much interrupt, but it's just more like sometimes, right? The natural way is that you talk, and before you finish talking, maybe somebody has an idea, they want to say it out loud right away. So there's no need to wait, right? So that's essentially what event-driven kind of approach allows you to do. It is this kind of asynchronous, this kind of things that you don't need to wait. It's kind of more efficient. It mimics more of the human situation. So that's what it is. So that's what it. So let me start then. Let's kind of go to some basic about events. So what is event, right? Kind of generically speaking, right? Event is a word that doesn't only tie into computing, but happens that we're doing computing work, and events has a special meaning for us. But let's take a look at some basic terminology. So from the dictionary, Merriam-Webster.com. So the very first thing it says, it's basically something just happens, an occurrence, right? Something that happens. And essentially that's what it is too. It's being used, to describe computing events as well. Now you kind of look through a couple more definitions, but for me, I think the fourth definition in here that I could find, on the Merriam-Webster.com is basically talking about the fundamental entity, right? It's very basic entity to describe, a physical reality. That the physical reality is about this event. The event is essentially represented by a point in the three coordinate in place, right? In space, you have the three coordinates. And if you are into math, right, math is X, Y, Z coordinate. That's the three-dimensional space. So essentially you have a point in that space. But the element that makes it even more special is the fact that it is in computing is really the time. So the time will keep changing too and never even stop. Even though, in the place you can stay at one place, but the thing is too, it will transform itself over time. So that's kind of a bit of an abstract kind of concept to it. But essentially that's what event is. And I find this explanation to be, so true, or at least this kind of address my concern. Is almost seems like time is a fourth dimension that makes events all the more special and mimicking or modeling how we function, right? Nothing stays the same, right? Things keeps changing, as we know. So that describes event, the point in time that it keeps changing. The point will keep changing. You're tracking all the changes, the change of state, for example, things like that. So this kind of brings in the theory of relativity. So you might be saying that, well, okay, this isn't about theoretical physics in this talk. Yes, obviously it is. But for me, I find it to be interesting. But we just have to keep in mind that that's what we're trying to do in computing, event-driven, event processing. All of these things is basically follow the events, through time and keep its state and keep its integrity. So, okay, so that's a very kind of quick introduction, or at least how I look at it. Then now, looking a bit then into, the title suggests event streaming and processing. So what is it, right? So basically, it is the practice, right, of taking action on a series of data points that originate from a system that continuously creates data. That's what event streaming processing is about. Now, going back to the event. So event is basically each data point in the system. But the stream describes an ongoing delivery of these events. So then now, kind of like you make it more complicated now, is basically a series of events. Basically, you can have different data points happening all in time. And that's what streaming data is, or this is actually the data streams. It's an ongoing delivery of these events in space and in time. And that's what it is. So that's what we're kind of tackling in this, conversation in here, in this presentation in here. So, and then the thing is too, then there's this terminology that we describe is about complex event processing. Now, complex event processing is basically, it takes just the events, not just the event streaming. It's basically complex, as the name suggests, right? This terminology, something more complicated. It's basically a set of techniques, right? For what does it do? It captures, right? And also analyze these streams of data as they arrive. And it brings value to it by, identifying opportunities or threats in real time. It has a purpose in it, this complex event processing. So it enables like systems and applications essentially to respond to any events or trends and patterns in the data as they happen. So then, in real life example, that would be, for example, a fraud detection system, right? Let's say, right, you have your bank accounts, and that's a prime example you can leverage on an event-driven approach to actually do fraud detection. Any kind of things, in your bank account, your money, all of a sudden, your account, the money gets debited, somebody's using the money. And then there are algorithms in there to analyze, well, where's the initiator coming from to actually debit the account. If it senses that something isn't right, it needs to react to it immediately. So that's the kind of the purpose, the benefits of using an event-driven approach. You don't wait for things to happen. You basically react to the event right away. And that's what it is. So complex event processing essentially kind of address this kind of solutioning kind of layer that basically you identify opportunities, identify threats, you want to react to it immediately. It's really the real-time aspect that it can enable you to do. So that's kind of complex event processing and allows you to kind of analyze the stream of data and react to it right away. So, and kind of really add value to all your systems. So. Now, let's kind of get back a little bit then into messaging aspect. I wanted to say too, there's always a confusion, I feel, in the world that we're talking about messaging. There's event messaging, there's also message-driven messaging. So let's clarify that a little bit. And also too, for this definition, I basically am borrowing too, and I find it to be so good, it's explained by Lightband, the company that invented Scala, and also by Dr. Martin Odersky, right? And the company also makes Akka, the reactive library, reactive systems, right? Akka and the whole collection of all these different libraries in there. So they describe messaging very well because that's their main business, dealing with messaging, dealing with streaming, reactive, kind of very reactive systems. So event-driven too, if we kind of comes down to the kind of elements, right? To the fundamental, it's basically, it describes the sender admits the messages, and then it doesn't know where the messages goes to because it's really up to whoever is interested. Let's say a subscriber, we call it a subscriber or the receiving end. If they need the data, they have to subscribe to the messages. Now, in order to be able to have this kind of event-driven systems where a sender admits the messages and doesn't care, you need somebody in the middle, and that's what we call a broker. Think of the broker is like a post office, right? And you need to send your messages and you don't really quite care. Let's say I'm a marketer. I want to send a bunch of, advertising messages to whoever will receive it, right? So I just bring it to the broker, to my post office, the agent, and tell him, okay, this is what I have, please deliver it for me. But the thing is, in order to be able to deliver it, then I want to label, somehow kind of categorize, because I might have, postcards about my cosmetic. I might have postcard about, maybe a man has cologne or something, a perfume or something, right? So all these things, you have different topics to label all your messages, and you basically tell your agent, in other words, the broker, to kind of take care of things for me. And then it's up to the receiving side to say, okay, I'm interested in cosmetics, so I subscribe to the cosmetic topic. And then when any message is coming from the producer that produces to that cosmetic topic, then the broker will deliver it to the client accordingly. So that's the idea. It pops up event-driven type of approach. Now, there's also then message-driven messages. So that actually is interesting. It's more about point-to-point, one-to-one, sender and receiver type of known to each other kind of relationship. The sender have to know who the messages is to send to. So you do need to have knowledge of the address, right, of your receiver side. And so the receiver side too, same thing. Sometimes you have bidirectional, then you also need to know who the sender is. It's a bit more like known. That's more about, that's really like message driven. So those are kind of the differences between the two. All right, so now then let's take a look to event-driven approach. And if we don't use that, what do we use, right? So actually the world too is all about, all about batch processing in the past. And event-driven actually came out, I think, is initially too. It's not that new, but it came out too in the 70s, 80s when we have telephone systems, right? Not even 70s, I think, is it the 60s? Maybe we already have telephone, in which it's really asynchronous conversation that needs to be happening. Otherwise, you are the old style of walkie-talkie type of synchronous style. So event-driven is not all brand new, but the thing is too, the way we do event-driven is a lot more sophisticated than it used to be. Let's put it that way. But we are still borrowing some of the fundamental kind of concepts. For example, Erlang, right? If you are familiar with Erlang, that language, they are the ones that does this actor model, to which is being, derived, by Lightband to actually implement the Akka library, is using the actor model. So as you can see, the concepts still apply. Anyway, so going back, batch processing. So that's what the world is mostly, was mostly about too, because there's an advantage to it too. at your company system, especially in the older days, maybe you have monoliths, right? You have only a couple big systems, let's say IBM. I used to work for IBM, so the IBM mainframes, it's busy processing all of these things that are happening during the day. Maybe you have a company retail system or airline system or whatever. You need to service all of your airline passengers, all that. And then things that needs to be changed, right? For example, there are employee information. Those that you don't need to be immediately kind of making, those changes. Then you can batch those information up. So that's when like batch processing also has its place too in the corporate world, because you want to gather all of the changes and then process them at a later time in which when the system isn't busy. So that's the idea. But the thing is too, event-driven has its own place, so is batch processing too. So I just want to kind of contrast the two. And the thing is too, with event-driven is what we are kind of going after in these days, because the world is moving faster and everything. So now the thing is then let's take a look more into the patterns, right? Event-driven kind of event messaging, event processing kind of semantics. Essentially, too, we have two kinds, and there's publish, subscribe, or producer, consumer type of interaction. And it's essentially, too, described by earlier when I talk about event-driven messaging. That's actually more of a pub/sub type of approach. Now, I already described publishing client will send the data and sends it to the post office, to essentially the broker. Broker is the middle person, the agent, to kind of figure out what to do with it. It's of course in reality all of the brokers too that we have in today's pub/sub systems, they tend to be quite complicated in the sense that you have different kinds of messages, how or when you want to deliver it. What if the network goes away? What if the network the client goes away? Things like that. It takes into account a lot of these different behaviors too. But the thing is, the simplest way of looking at it is publish the data, and broker will deliver it accordingly, and then deliver to who? Deliver to those subscribers who have subscribed to this topic, right? That carries the data with it when the data arrives. So that's kind of streaming too. That's essentially what we call about streaming. And as you can see, if we're doing pub/sub, the advantage of it is that it can scale really, really well, because you can, the broker can handle many messages. It essentially will kind of like control the flow too in some ways for all the messages that comes in. So that's kind of a pub/sub semantics that you can use. Another way of doing it is basically using message queues. And I'm sure some of you are already working with it. Now, the thing is, there are like older kind of message-oriented type of messaging systems. For example, like IBM has MQ series, right? Those are kind of message queuing. So a message queue is different. It's really about, it's also asynchronous service-to-service communication, and it's mostly to using in serverless and microservices architecture. So messages are stored in the queue until they are processed, and then they get deleted. And that's the differences too, is that message queues, essentially, you have only one recipient, one single customer, your sender, and then going to the consumer, one's consumer. So once it's being kind of received, and then you signal to the broker itself that essentially too, you can delete it. So essentially too, the idea of such is that you have sort of a dedicated kind of recipient. In this case, is a one-to-one, point-to-point kind of communication to it. And again, it helps to kind of offload, decouple the sender and the receiver, just like pub/sub is as well, but it's a point-to-point way of doing things. So, all right. So now then, let me kind of explain a little more about event streaming. Is essentially a step beyond just messaging, event messaging. Now, very often these days when we work with systems that are very sophisticated like Kafka, it does the distributed messaging really well. It takes care of all the messages that comes in. Think of it as like a distributed logging kind of mechanism that it does. Pulsar also does that too. But the thing is too, all of these, right? So let's kind of try to understand why, right? We're doing all of these things, but we need to understand why. So essentially, what is driving it is that we want to have real-time data. We don't want to wait. We want kind of data comes in and immediately be available for us to do whatever it needs to do, to analyze, to doing complex processing, event processing, for example. So the advantage of it is that if you can do things in real time, if you're a business, right, you are kind of doing things for your customers. Your customers don't want to wait too long. I mean, you can wait a little bit. Okay, that's fair. But the thing is, you really don't want to wait too long. And that's the idea. You want things to be done quicker. the real time. Think of the fact that, there are example of, let's say you are, all football fans, right? Soccer, right? In America, we call. And let's say you have some favorite players that you have, and you want to immediately, let's say you're playing a game, you want to see the statistics of your favorite player. And if whatever this player is doing, how many shots on goal he has, or how many, passes he has, misses, and all these things is immediately captured and sent to the server. It can be processed right away and display it. So then on your phone, on your app, right, you immediately look up your app and say, hey, my favorite player, and you have to tell me which is your the best player in Dominican Republic. But I know too, in Latin America, a lot of really great players. Anyway, so you want to look up your player. You want to see what the statistics is. You don't want to wait. You want to see it as the game is happening, right? So that's an example usage. Another usage of it is, in today's world, we're talking about AI, machine learning, all these things, and they are processing huge amounts of data. These data too, you need to have it go through processing, right? It's just they come in, and you don't want to wait. You want to ingest all your data quickly and being able to ingest it and have it kind of have transform right away and do something about it, essentially, right? And essentially in machine learning too, that's the interesting thing. As if you are working with machine learning, as you have sort of a continuous deployment type of scenario. Unlike just DevOps thing, right? You are actually analyzing as your data coming in. You need to analyze it and basically also have to update your model right away and deploy it right away. Think of the speed that it needs. So using an event-driven approach, event streaming type of approach would be ideal, because you supply all your data into your data pipeline really quickly, and then immediately you can enable it to be analyzed, maybe pipe it to some like algorithmic kind of thing and analyze all of these things, and then immediately update your model. Your model will get deployed right away to your target server, and the whole cycle can be happening real fast. So that's another kind of good example of how you can leverage on event streaming to help with your AI and ML machine learning type of deployment, for example, ML ops, right? Okay, so then another kind of big advantage of it is really scalability. Think of the fact that you have tons of messages coming in, and all of these brokers are installed, let's say using a cloud native kind of way, like install into different, into your cluster. And then you get more and more data coming in, and then you want to spin up more broker to handle all of the data that comes in, and you have new topics and whatnot. And basically with this kind of approach, you are detaching the sender and the receiver using broker to handle. You can basically increase or decrease your number of brokers and doing everything in a very scalable fashion, especially in a cloud way. So that's why too, event streaming as such, is also an ideal approach for you to kind of handle situation in which you'll be expecting data spiking up and down, the workload spiking up and down. So those are kind of example as to why. So again, this is just a quick kind of summarizing. Basically, watch for the events with the system or application, subscribe to the topics to see certain event types, and make decisions on data in real time, not after the event, and being able to ingest high frequency of messages, but with very low latency, kind of sending back any kind of outcome that you're expecting. Now, then let me introduce to you Apache Pulsar. What is Pulsar? Apache project, we know it is Apache Software Foundation is all about open source. And Apache Pulsar was actually initially designed and developed and implemented by Yahoo, the engineering in Yahoo, engineering teams. And so they contributed it. They started, I think, in 2012 or 13, kind of earlier, about 10 years ago, essentially, right? 2012 or so. And then after about 3 or 4 years, they decided to kind of donate it, and they contributed to the Apache Software Foundation. And then very soon after that, it's like in less than 2 years, in 2018, it became a top level project because everybody is starting to recognize its importance. And why? Because it has already, the design of it is already taken into account that my runtime is going to be in a cloud environment. It's very cloud native, kind of in its DNA. I call it DNA. I was actually recently at a conference, right, in Spring I/O in Barcelona, and someone asked me and said, well, would you describe Pulsar as something like, Kafka on steroids, right? So sort of like you kind of like pump something into Kafka to make it powerful in the cloud. But, when I step back, I'm thinking, what? It's not the same. Pulsar really is being kind of designed from scratch, and it takes into account the cloud native aspect. So it comes out very, very much kind of cloud native ready. So it's in its DNA, is what it is. So essentially, it's cluster based and multi-tenant, and also has a very simple client APIs. Currently supports Java. Is written in Java, and also supports .NET too. So if you're a .NET developer, that also will work, as you can write your broker in .NET. Not broker. I'm sorry, producer in .NET, or your subscribing client in C#, for example. And then Python and Go, those are kind of the primary client APIs, but there's also community contributions such as Scala client. It also supports Ruby, things of that, all kinds of languages too, that you can, because of its open source nature, you can also participate in it. You can also apply, right, and join the project as well. Now, another thing about Pulsar is that really its strength is that it separates out the compute and the storage part. Imagine, right, this kind of distributed logging system is handling, like, especially, let's say in a machine learning, kind of algorithms kind of way, you're handling data in kind of like billions of rows of data coming in all the time. So now the thing is that Pulsar can handle managing all of the logging, but as you can see, it can get to be quite a lot, a lot of work. So it's smart enough, the designer is smart enough to separate and said that, well, that itself is a full-time job, of its own. So why don't we kind of delegate it to somebody else to do it? And guess what? They pick another open source project. Is essentially Apache Bookkeeper. Apache Bookkeeper is the one that manages that, kind of responsible for managing all of the distributed logs that it has to happen, right? That goes to the broker, all of these things. So it's kind of nice in that sense, because then Pulsar can then focus on dealing with the compute side, messages coming in, going through the broker. It also already is very complicated dealing with all of these messages and deliver all of these things. And so basically it offload it to Bookkeeper to help it with managing all of the distributed storages and all of these things. So okay, another thing too about Pulsar is, doing like asynchronous kind of messaging. We know, asynchronous messages is more like you send a messages and then guess what? It's like you on a big boat. You drop something into the ocean and you don't know what happened. But guess what about Pulsar? Pulsar actually has guaranteed message delivery also built into. So all of the quality of service, it takes care of things for you. So it guarantees that basically messages always gets delivered at least once, for example. And the different QoS kind of level too, it also supports. So, and then another thing too about, Pulsar is that you might say, well, I'm collecting all these data, but the thing is the data itself, I want to transform it as it goes through the pipeline. And guess what? Pulsar has this capability feature called functions, right? So Pulsar function also has a framework. It's inspired by Amazon, the AWS Lambda kind of concept, and like GCP has the PubSub too also has its own function, right? Azure also has function. So it's kind of like that because it's becoming necessary. You're dealing with some data that flows through. You want to transform it quickly and not having had to rely on any external library. Basically, Pulsar has it too. You can essentially leverage on the function to kind of do some transformation. And if there's time, I can quickly show you how you can easily write a simple, for example, a Java client to handle Pulsar function. And then another thing is basically the tiered storage offloads. So basically, too, you're dealing with a lot of messages. And over time, you basically know that, well, the messages hasn't been touched, I'm all done. So in that case, you don't want it to be occupying your primary storage. You want to offload it to long-term code storage. So Pulsar has the built-in capability of taking care of things for you. So how nice, right? It's more like, you think of Pulsar, really think beyond just your messaging. It's taking care of a lot of those tedious, yet very necessary administrative type of work for you. So that as developers ourselves, we don't necessarily have to deal with all of these kind of things. It's like you owning a new house, right? A big house. You don't want to clean every room. You hire somebody to clean it and take care of things for you, take care of your kitchen, all these things, and cook for you, for example, something like that. So guess what? You can enjoy your house, but still you need to do work, but it's less of a chore for you. So, all right. So again, let's kind of review a little bit what is Apache Pulsar. I know I kind of went through it quite quickly, but as you can see, if I summarize it, it's basically a unified distributed messaging and streaming platform. It's open source and originally was developed at Yahoo, and it's becoming Apache Software Foundation top-level project in 2018. It's very much of a cloud-native system, cloud-native streaming, all capable running of Kubernetes and multi-cloud, hybrid cloud, even on-prem. You can also run Pulsar as well. Okay, so as you can see, a couple of graphs that I'm showing you, you can see too, the open source project is gaining popularity. There are more stars now as it goes through time, and the more contributors and also monthly active contributors are also increasing as well. And who else is using Pulsar? So as you can see over here, right? Yahoo is still using, some teams in there are still using, Verizon, Splunk, all of these too. They're actually an increasing number of companies that are considering using Pulsar because of its being very capable and robust and also able to run in the cloud very easily. And Pulsar is different. Let me kind of like handle it. Now, this one I already kind of described, right? Producer, consumer, broker, bookkeeper, and zookeeper. These are essentially the 5 kind of fundamental components of a Pulsar system. And then also, too, this one is also kind of a summary of what it is that it takes on a very tiered architecture design too, and it's basically supports like vertical scaling and horizontal scaling really well. Now, one thing I want to point out is that very often too in kind of distributed messaging systems, right, and tons of messages coming in, you need to also scale too. You often can get spike, right, all these data that's coming through. And so if you think of it, right, I have my broker handling all of my messages, and I have topics, and there are also another concept called partition topic, because you want the topics to spread across different brokers, things like that. Now, what if you often say, well, I have too many messages coming in, so let me add, another cluster, another server to this whole cluster. And guess what? Then you have to worry about rebalancing all of your topics and partitions on each of the broker. You originally have 10 brokers, now you have 20. How do you spread them across? Things like that. Now, the thing is too, in previously, right, a lot of the older kind of streaming platform or messaging systems, you have to do things by hand, meaning manually. You have to calculate, well, how do I move things around? Then you have to do that manually and kind of spread your topics across by yourself. But Pulsar, that's a nice thing. It has this built-in capability of knowing that, okay, you are adding another cluster, so let me do all the rebalancing for you. So that's kind of like really good if you think deeper about it, right? So real nice, because this kind of administrative stuff, Pulsar has thought ahead of time, will take care of things for you too. So it's really nice, right? So also another thing is the tightly coupled persistence and messaging serving capabilities don't exist in Pulsar, because we separate out this compute, again, separate out and have a bookkeeper taking care of all of the bookkeeping, the log messages, all these things. So basically all of these challenges, right, that previously existed, to developers, we don't have to worry so much in Pulsar, because Pulsar already knows that you need to do it. I'll take care of things for you. It's like a concierge if you fly, right? Doing flying, you basically tell it, I need to go from A to B, and it takes care of all of these small things for you. It called the taxi for you. It called, the hotel ahead of time to prepare your room. Things like it's kind of that kind of concept. So that's what I want to kind of emphasize to you. And this thing too, I just want to really quickly kind of point out Bookkeep, right? Bookkeeper is in itself a very complicated thing. But if you want to check into, please do, into Apache Bookkeep. But just want to point out is that it really is a sophisticated log messaging type of handling system, and handles all the storage. It guarantees, all of these write and read, is really fast too. And also guarantees its integrity, so then you don't lose your messages. And there's this wall-based, kind of specification, is write-ahead logging kind of specification. It adheres to that too. So you can kind of check into those. And if you're worrying about message replication, it has all these ensemble size, write quorum, act quorum, all of these. It handles all of these things in a very sophisticated way. So that's why I want to point out. Again, Apache Pulsar solves the problem of bolt-on, right? It represents the next generation of enterprise messaging. It's a unified solution for pops up, for queuing, for streaming, for message remediation and enrichment too. So it's really like a very nice thing. One platform, it does things for you. And it out of the box, it supports cloud, on-prem, hybrid cloud, and also this concept of geo-replication, especially if you deal with big companies with different data centers in different parts of the world. It actually handles the replication for you very nicely as well. And also has multi-region support and a data lake, data store, data warehouse type of integration, and much more too. All right, I won't kind of step through all of these because I realize that I'm kind of speaking a little over time, but really quickly is to kind of tell you the differentiator. It separates between compute and storage, right? The compute, basically it handles the broker side, and so the storage is delegate off to bookkeeper. That's an advantage. The geo-replication part, just want to quickly kind of show it to you, right? So it's kind of nice, it comes to like disaster recovery or kind of more like replication. It has this capability of doing geo-replication for you, right? For example, these different patterns of synchronous versus asynchronous, active, passive, and selective message replication, all of these things too is already kind of built in. It's a matter of configuration from the user side, right? So, and it helps to meet like data compliance requirements across different geo regions too. Another thing is the multi-tenancy. If you think of a Pulsar cluster, right, you want to further subdivide all of your data. It actually already has built-in like different tenants where essentially think of it as like, an apartment building, let's say, you have self-contained kind of unit, right? But it's kind of using an example of a company. You can have a finance department in one tenant, marketing and another tenant, and product as another tenant. So then they all manage their data independently, but together they are under the same cluster. So that's another kind of a very kind of a strength of Pulsar too. And this one too, I wanted to point out the fourth differentiator is a very flexible message processing model. Now, I mentioned about Apache Pulsar having the PubSub capability, also has queuing by essentially using the exclusive subscription mode. Now, as you can see, there are different subscription mode that you can do from the client side. You can have exclusive, essentially that is equivalent of enabling message queuing from within Pulsar. So that's kind of a very unique capability in Pulsar. You're doing PubSub, you still are doing, depending on the broker, to do things for you, but on the subscription side, you can make it like one-to-one message queuing. And then there's also failover subscription is essentially you define, essentially still kind of dedicated consumer, but you have like a failover, a secondary consumer for you. In case the primary fails, then you have secondary to take over. And then the third thing is about shared subscriptions, basically multiple consumers for the same subscription, very useful in a cloud native environment. Now, if you want to go a bit further of ensuring the messages gets kind of delivered in the same order as it's being published, you can use key shared subscription too. And that's also for multiple consumer, and they kind of have a shared subscription, but messages guaranteed to be delivered in the order that it was being published. So these are different modes. Okay, so why Pulsar, right? So essentially, I just want to really quickly kind of summarize. It's very flexible. It can act as a distributed log like Kafka or pure messaging system like RabbitMQ. It has multiple types of subscriptions, several delivery guarantees, retention policies, and several ways to deal with also schema evolution too. Now, I don't think if I have time to go through everything, but I want to describe, Pulsar has the data, supports the data pipeline kind of thing. It's like water flowing through a system, the different pipes. Getting into this thing is the part that I want to describe. It's like Pulsar that transform everything, and then it outputs it to a sink. And that's the idea. So you can basically build a system connecting to different data pipes too. So that's the kind of nice kind of architecture that it supports too in your particular application and ecosystem. And this is Pulsar functions. I already kind of talk about it, so I won't get into more detail now. Pulsar function. And there's also the concept of Pulsar schema, because anytime you want to do messaging, right, it's going through the wire. So if you don't kind of deal with the type, then you have to worry about serialization and deserialization itself yourself, right? By default, it's kind of transfer all the data as byte arrays. But as you know, byte arrays are just more low level for you to deal with. So the nice thing about this Pulsar is we have this concept of schema. So it supports like different kind of schema type too. So if data type changes, you can also alter your schema. So then it can help you. So the different kind of schema type supports like primitive type, key value pair or Afro, JSON, protobuf type of schema too. And it helps with the evolution of your schema, and also has managing. You can manage it automatically or manually as well. Okay, so then last kind of feature I want to highlight among many other features is the Pulsar I/O. So if you have different syncs that you want to build, right? Currently we have Kafka, we have all kinds of like database sync too, but then you can also build your own sync is what I want to try to point out. All right, so their data stacks flavor, we have Astra streaming, Luna streaming, and the open source. But I won't go into all the details right now. But what I would like to do, I don't have time to kind of do the demo now, but I want to kind of show you all of the resources in here. Please kind of check out my slides to check all of these links that I have in here. But I want to highlight too, there's astra.datastacks.com. If you want to play with it, come to our datastacks.com. You don't need any credit card, and then you create an account. Basically, you can go in, for example, right? Go in, and then it will give you a console, and you can actually create your Cassandra, and also then add in like Pulsar streaming as well. This is kind of taking a bit of longer time, but essentially, yeah, this is what it is. So you can actually do create stream and play around with Pulsar stream. So, okay, so all these is basically in here, astra.datastacks.com. And then this is Astra DB. If you want additional credits, you can use this code. So download my, or look at, or link to my slides, and you can get to this. And also my Twitch stream is on here. This is how you can get to it every Wednesday afternoon, US Central Time. And also join our Pulsar neighborhood. And also our Pulsar neighborhood is the wiki page. You can contribute content to it too. And there's also a meetup group that we're trying to start. It's called Apache Pulsar Neighborhood Meetup on meetup.com. And with that, I want to thank you. And sorry, I go a bit over time. I always get excited when I talk about this topic. So please stay connected with me follow me on Twitter, my LinkedIn, and also connect with me on my Discord. So with that, thank you very much and really appreciate. I think I see some questions, right? Yeah.
Thank you, Mary, for this talk. Amazing, very well explained. Thank you for introducing this concept to us. Also, yeah. Thank you to the attendees, 144 attendees already. And wow. Yeah, that's amazing. Thank you for sharing with us. And as you were saying, there are a couple of questions. The first one, can I use Kafka with Apache Pulsar?
Yes, you can. You can use it too. Now, there are also other vendors. For example, Stream Native is the company that actually they are the Yahoo engineers that's formed that Stream Native. They also have enabled like Kafka connector to Pulsar. I want to also emphasize DataStax recently released like Astra streaming, and we have Kafka connector capability. So yes, perfectly, you can use it with Kafka. So.
Good. Thank you. Next question. What are the advantages of Apache Pulsar over Kafka? They are related.
Sure. Yeah. So I think in my presentation, I want to highlight, among the many advantages is basically Pulsar itself is very cloud native ready, as you can see, right? It separates out the compute and the logging kind of mechanism. Logging is delegated to Zookeeper. So Pulsar can focus on all of the compute side of things. That's one thing. So it makes it very scalable, much more easier. And it's designed with like cloud native in mind. So if you want to do, geo-replication, multi-tenancy, all of these are already built in. So let's say, now I have to kind of say, I have to compare with Kafka. Kafka too, if you want to do replication disaster recovery, you have to actually do a lot of calculations. But that's the nice thing about Pulsar is that Pulsar has already very flexible. It knows certain things. So then it does a lot of these kind of more like a housekeeping kind of work for you. So I think that's also another really good advantages of Kafka. So yeah.
Good. And thank you. And last question, does Apache Pulsar provide built-in monitoring features?
Oh, okay. Very, very good question. By Pulsar itself, I think there are different ways you can write the code if you look into the SDK. Now, the thing is I want to kind of highlight, for example, DataStax too, is that I was showing you the Astra database.com. There are some minimal, if you just use our Astra console, create your stream, you can actually look into their statistics show that if you have topics subscription, what is going on, the basic monitoring it has too already in the DataStax console. Now, if you want to do kind of fancier like with Grafana, with Prometheus, all these, yes, you can also do that, but it's not kind of so to speak like out of the box yet. You have to kind of do the connection yourself. So yeah.
Good. So
Yes.
a last question is, what do you think is like the greatest challenge when you try to implement Apache Pulsar?
Oh, Pulsar. Okay, I do have to say that because Pulsar is not, very old yet, it's still growing. So there are some of the features and how do you use, for example, like a Pulsar admin on the command line, all these small things, you're going to encounter a bit of a roadblock, right, in the beginning. Just like anything else, you kind of study new. And a lot of these like command line things, it may not be as kind of easy, right, so to speak, or simple to just out of the box and run it or something. And you have to kind of figure out, okay, these are the parameters I need to use for my command line. Those things, I think, maybe a bit of an initial kind of annoyance, right, when you try to learn something new. And I think it's kind of typical of any software. When you first come out, usually the UI isn't as refined. But the thing is, the project too, we're refining all of these things. So you can expect it to be better over time. Now, there's also a lot of growth towards integrating with any kind of data warehouse. All these, they are still kind of growing in that aspect. There are also things that we are working with to, kind of work with analytics, right? Data analytics. Those things, I think, is not bad, but it's a growing aspect, and you can expect some bumps, in the beginning when you try to integrate. But certainly, we're moving in that area in which Pulsar can be easily integrated with other kind of functionality, other libraries to do more kind of meaningful things, more capable things. So yeah, but great question. Everybody asked great question. Thank you so much. So yeah,
Thank you, Mary. It's been a pleasure to have you here. You are
thank.
already invited to our JConf Dominicana 2023.
Oh yes.
Hopefully, hopefully it's gonna be already. Maybe you can participate in a workshop and you can come to DR. You are welcome here as well.
Yeah,
So
I would love. Yeah.
thank you, and we are now going to go to our next session. Vamos a tener ahora el panel. Se quedan aquí que nos llevan. So
Thank you.
thank you.
Gracias. Gracias. Bye bye.
De nada.
Bye bye. Bye.